on October 21st, 2025, while you were scrolling online during breakfast, or perhaps sleeping on the other side of the world. An unprecedented event occurred. The United States Space and Aeronautics Agency activated its planetary defense network. The network was activated not for an asteroid, nor for a near-Earth object that had been tracked for years, but for an interstellar visitor. For the first time in human history, the International Asteroid Warning Network, the very coordinated system designed to save humanity from a civilization-ending impact, quietly activated its global web of telescopes and pointed every available instrument at a single target, 3IAtlas, a comet that wasn't supposed to be here, you would think. An event like this would dominate every news cycle, every headline, every conversation. But it didn't happen with a press conference. No dramatic announcement. Instead, precisely at 21:10:08 Coordinated Universal Time, a single PDF document appeared on the website of the Minor Planet Center. It was Bulletin 2025 U-140. 26 lines of text buried in technical jargon that most people would never read. An editorial notice announcing a dry, astrometric campaign, clinical and forgettable, except for one detail that changed everything. The target was BAI-Atlas, an interstellar object, and the organization running this campaign was the International Asteroid Warning Network, the planetary defense system. Now, before we go any further, I want to hear from you. Go ahead and press that like button, subscribe to the channel, and let me know in the comments where you're listening from. What time is it there? And honestly, does this whole thing sound like a story of a cover-up to you? Help our community grow by sharing this video and hitting that notification bell below. Thank you for your support. Now, let me be clear about what the International Asteroid Warning Network is, because this isn't some academic study group. This isn't a collection of hobbyists with backyard telescopes. The International Asteroid Warning Network is the operational backbone of planetary defense. When an asteroid is found on a collision course with Earth, the International Asteroid Warning Network is the entity that coordinates the global response. They synchronize observations across 6 continents. They calculate impact probabilities. They advise governments. They are the ones who would tell us if we need to evacuate cities or launch deflection missions. Their mission is simple and terrifying: find the threats, track the threats, and give humanity enough warning to do something about them. They test their coordination on critical objects, potential hazards, anomalies, and high-interest targets, not ordinary comets, not objects in safe orbits, but the ones that could change everything. And now, for the first time ever, they have activated for an interstellar visitor, a visitor that, according to every official statement, poses no threat to Earth, a visitor that will not come anywhere near our planet, within 270 million kilometers. That's the part that should give you pause. That's the part that doesn't add up. The bulletin itself is a masterpiece of understated language. It announces a cometary astrometry campaign, lasting from November 27th, 2025 to January 27th, 2026. The stated purpose is to introduce methods to improve astrometry from comet observations, enhancing the observing community's capability to extract precise astrometric measurements. They are framing this as a training exercise, a workshop, an opportunity for astronomers to refine their measurement techniques on a challenging target. And the challenge, they explain, is that comets are extended objects with morphological features, like tails, that can pull their center of mass measurements systematically away from their central brightness peak. That sounds reasonable. That sounds scientific. That sounds like precisely the kind of technical problem that astronomers love to solve, except for one glaring issue. 3IAtlas isn't behaving like the comets they are describing. Its photocenter, the point from which most of its light appears to originate, is not aligned with its predicted orbital position. The light and the mass are offset. That is the anomaly they are admitting to in the fine print. That is the problem they are trying to solve. And it is a problem that has been quietly discussed in academic circles for months. An object whose brightness doesn't match its orbit. An object that seems to glow from the wrong place. Now, think about the timeline they've laid out. The campaign doesn't start immediately. It begins on November 27th. Why that date? Because 3IAtlas reaches perihelion, its closest approach to the Sun, on October 29th. It then spends the next month emerging from the Sun's glare, moving back into the observable range of Earth-based telescopes. The International Asteroid Warning Network's observation window opens precisely when the object becomes visible again after its solar conjunction, after it was hidden behind the Sun for weeks, after it has passed through the only region in space where we cannot observe it. The schedule is very precise. Workshop on November 10th, kickoff meeting on November 25th, observation window opens on November 27th, mid-campaign check on December 9th and 10th, window closes on January 27th, final teleconference on February 3rd. This is not how you organize a routine training exercise. This is how you coordinate a multinational surveillance campaign. This is how you ensure every major observatory on the planet is looking at the same object at the same time, collecting the same type of data, and feeding that data into the same analysis pipeline. And here is what makes it even more interesting. The workshop on November 10th requires registration. Only workshop participants can join the campaign. That means they are vetting the observers. They are making sure everyone involved understands the protocols, the data formats, the reporting requirements. They are creating a controlled group of vetted astronomers who will all be looking at 3IAtlas during its closest approach to Earth in December. Registration closed on November 7th. That was 2 weeks ago. The list of participants is not public. We don't know which observatories are participating. We don't know which telescopes will be retasked for this campaign. We don't know what specific instruments they will be using or what types of data they are prioritizing. All we know is that by the time 3IAtlas makes its closest approach to Earth, on October 19th, the entire planetary defense network will be silently watching, systematically, unobtrusively. Let's talk about what astrometry really means in this context, because this word gets mentioned a lot, and most people don't realize how important it is. Astrometry is the precise measurement of the position and motion of an object, like an asteroid or a comet. Good astrometry tells you exactly where it is, where it has been, and most importantly, where it is going. It allows you to calculate an orbit with enough precision to predict close approaches years or even decades in advance. It allows you to determine whether an object will impact Earth or pass by with a safe margin. It is the bedrock of planetary defense. When they say they are improving the astrometry for Atlas, what they are really saying is that the current measurements are not good enough, that the orbit is not as certain as they would like. The predictions have too much uncertainty, and for an object that poses no threat, that shouldn't matter. You don't need millimeter precision on the orbit of a comet that will pass us at a distance, and of nearly twice the Earth's distance, unless you are worried it might not pass us by, unless you're worried the orbit could change, unless you are tracking something that could alter its trajectory during perihelion. The Oberth effect. That's the term that keeps popping up in technical discussions. It's a principle from astronautics that says the most efficient place to change a spacecraft's trajectory is at the point of highest velocity, at perihelion, when the object is moving fastest. And as gravitational potential energy is maximized, a small thrust applied at perihelion can produce a large change in the orbit. Ultimately, if you want to decelerate from an interstellar velocity and enter a bound orbit around the Sun, perihelion is where you would do it. And for Atlas, perihelion occurs on October 29th, 8 days after solar conjunction, 8 days after it disappears behind the Sun. From Earth's perspective, that's 8 optimal days to maneuver while hidden from view. I'm not saying Atlas is performing an Oberth maneuver. I'm saying the National Aeronautics and Space Administration is organizing a surveillance campaign, and a 2-month-long one that begins precisely when we could detect the consequences of such a maneuver. I'm saying they are coordinating the planetary defense network to watch for orbital changes, outgassing anomalies, or fragmentation events that might indicate something other than natural cometary activity. I'm saying the timing is too precise to be a coincidence, and they're not hiding this. The bulletin is public. Anyone can read it, but it's written in the language of bureaucracy and technical protocol, designed to be boring, designed to be overlooked by anyone not deeply versed in the field. Its transparency is camouflage, hiding in plain sight by being too tedious to notice. There's another detail in the bulletin worth noting. They mention that cometary bodies pose unique challenges for astrometric measurements, for precise astrometry, which is true, but they also note that Atlas is being used to exercise the community's capabilities. Observing from that capability is very interesting. Not the precision, not the sophistication. Capability. Capability is something. The ability to coordinate a global observation campaign on short notice. The readiness to track a fast-moving interstellar object as it transitions across different regions of the sky. This is an exercise, but an exercise using a real target. It is preparation for the day we discover an interstellar object that truly poses a threat, or it is a response to an object that has already triggered all internal alarms, and they are using the language of an exercise to keep the public calm while they figure out what they are dealing with. Let's consider what happened with the Mars flyby on October 3rd, BAI. Elias passed within 30 million kilometers of Mars. Many spacecraft were positioned to observe it. The Mars Reconnaissance Orbiter, with its high-rise camera, is capable of resolving features down to 30 centimeters per pixel. The ExoMars Trace Gas Orbiter with its Cassis imaging system. Mars Express with its HRSC camera and its Omega spectrometer. The rovers of the National Aeronautics and Space Administration. On the surface, Perseverance and Curiosity pointed their cameras to the Martian sky. The European Space Agency published some images from the flyby. The comet appeared as a slightly fuzzy white dot against the background stars. Exactly what you would expect from a fast-moving object at that distance. But the National Aeronautics and Space Administration has not released anything. No high-rise images, no spectral data, no press releases celebrating this unique opportunity to observe an interstellar visitor from multiple vantage points simultaneously. The silence is suspicious. High-rise is one of the most powerful cameras ever sent to another planet. It can resolve details smaller than a dinner table from orbit. At a distance of 30 million kilometers, it should have captured the best images of BAI-Atlas we have ever seen. Images that would reveal the size of the nucleus, the structure of the coma, any jets or outgassing patterns, images that would answer fundamental questions about what this object truly is. And those images exist. They were taken. The data was transmitted back to Earth, but it has not been released. Not to the scientific community, not to the public, not even as a raw data set. There are two possibilities. Either the images show nothing unusual, and the National Aeronautics and Space Administration has simply not gotten around to processing and releasing them, which would be very strange given the level of public interest. or the images show something that requires careful, coordinated analysis before any public announcement. Something anomalous. Something that changes the assessment of what 3IAtlas might be. And now, less than 3 weeks after that Mars flyby, the International Asteroid Warning Network activates. The Planetary Defense Network initiates a characterization campaign. A global astrometry campaign is announced, with a closed workshop and registration requirement, and a 2-month-long observation window, timed precisely for the object's closest approach to Earth. You don't do that for a normal comet. You don't do that for an interstellar visitor that poses no threat. You do that when you need. Every telescope on the planet tracking the same object, gathering the same data, ready to react if something changes. You do that when you are tracking something that might not follow its expected trajectory. You do that when you are preparing for unexpected situations that you are not yet ready to discuss publicly. The document ends with a simple, bureaucratic sign-off. Minor Planet Center staff. Copyright 2025 Minor Planet Center. No drama, no implication. Just another day at the Minor Planet Center. Just another editorial notice in a series of endless bulletins about asteroids and comets and orbital mechanics, except this one was different. This bulletin activated a network that had never before been activated for an interstellar object. It coordinated a campaign on an object that officially posed no threat. Its observation window was timed to coincide with the exact period when we could detect any deviation from a purely gravitational trajectory. 3IAtlas is currently behind the Sun, invisible to Earth-based telescopes, moving through its perihelion at a speed exceeding 68 kilometers per second. Bathed in solar radiation that could trigger outgassing, fragmentation, or surface changes, positioned at the optimal point for any propulsive maneuver, natural or not, and for 40 days. As it emerges from the Sun's glare, the entire planetary defense network will be watching. Every major observatory, every participating astronomer, every instrument capable of tracking a fast-moving target in the pre-dawn sky. They are not telling us to panic. They are not telling us to prepare. They are telling us this is a training exercise, an astrometry workshop, an opportunity to improve measurement techniques. And perhaps that is exactly what it is. Perhaps, maybe the activation of the International Asteroid Warning Network is purely procedural. Maybe the classified registration and the coordinated observation window and the suspicious timing are all just standard protocol for any interesting interstellar visitor. Maybe the silence on the Mars flyby images is just bureaucratic delay. Maybe there's nothing unusual about 3IAtlas, other than its interstellar origin, its enormous size, its strange spectral signature, and its anomalous light curve, and its perfectly timed perihelion during solar conjunction. Or maybe, just maybe, they are tracking something that gave them a reason to activate planetary defense. Something they saw in those high-rise images that have not been released. Something in the orbital data that does not fit the models. Something that justifies activating a global coordination network and staging a 2-month-long surveillance campaign under the cover of an astrometry training exercise. We will find out in December, when the observation window opens, when 3IAtlas emerges into the morning sky, low on the horizon, moving through the constellation Virgo, as hundreds of telescopes track its position every night, measuring its velocity, brightness, spectral signature, and stability, as the data comes in and is analyzed and compared against the predictions, as we see whether it follows its expected trajectory, or if something has changed during those hidden weeks behind the Sun. For now, all we have is a bulletin, 16 lines of text, an editorial notice about an astrometry campaign, and the quiet activation, understated for humanity's planetary defense network, for an object that poses no threat, for a visitor that would pass at a safe distance, for a comet that should have, as required, no coordination from the International Asteroid Warning Network. Unless it was more than just a comet. Unless there was more to this story than the official account. Unless someone, somewhere, had seen something in the data that made them decide it was time to activate the network. Time to coordinate a global response. Time to watch very carefully what happened next. The countdown had begun. November 27th. The observation window opens. October 19th. Closest approach to Earth. January 27th. The window closes. And somewhere in that timeline. And we would find out if this was just an exercise, or the preparation for something we were not yet ready to acknowledge. Chapter 2. The Whistleblower's Bombshell. 12 hours after that news broke, and someone broke their silence, not through official channels, not through a press release, or a scientific paper, but through a social media post that has now been viewed millions of times, and it ignited a firestorm of speculation that space agencies around the world are refusing to address. A person claiming to be an engineer and space debris analyst at the European Space Agency came forward with information. They said the public deserved to know information about 3IAtlas that, if true, would change everything we thought we understood about this object. The post appeared on the platform X around 1900 hours, at Coordinated Universal Time on October 21st. The account, which had been relatively quiet for months, suddenly posted a detailed thread claiming it inside knowledge of the European Space Agency's operations and access to data that had not been shared with the broader scientific community. The core claim was extraordinary. According to this alleged insider, the Fermi Gamma Ray Space Telescope had detected a stable signature coming from 3IAtlas in mid-September. Not a burst, not a fluctuation, but a steady, continuous emission that didn't match, as any known natural source in the database. Let me be very precise about what that means. The Fermi telescope is designed to detect gamma rays, the highest energy form of light in the universe. Natural sources of gamma rays include pulsars, black holes, supernova remnants, and active galactic nuclei. These sources create characteristic patterns. Pulsars pulse, black holes flare, supernovas fade over time. Each has a signature, a fingerprint in the data that tells you what you're looking at. What Fermi allegedly detected from 3IAtlas was none of those things. It was described as steady, continuous, artificial. The whistleblower used specific language. They said the signature could not be attributed to any other celestial source. That's not casual phrasing. That's the kind of language you use when you have checked every natural explanation and ruled them all out. It's the language of someone who has seen something they cannot explain through conventional astrophysics. And then they added the clincher. In other words, the object is emitting a constant, engine-like hum. Now, obviously, gamma rays are not sound waves. Space is a vacuum. There is no medium for sound to travel through, but astronomers often describe electromagnetic signals as sound, because it helps convey the regular pulsing pattern of a pulsar, which is often converted into sound, into a rhythmic pulse. Solar flares create bursts of radio noise. That sounds like static when converted to audio. What this supposed engineer was describing was a steady hum, a kind of continuous sound. The signal you would expect from a power source running at a fixed frequency. The kind of signal that does not occur naturally. According to the Post, this discovery was made in mid-September, which would be about 6 weeks ago, right around the time Atlas was being observed by multiple telescopes during its Mars approach. right around the time when spectral analysis was revealing all the strange anomalies in its composition, right around the time when Harvard University astrophysicist Avi Loeb began to publicly question whether this object could be something other than a natural comet. And according to this whistleblower, the Fermi data was never shared in the usual analysis channels of the European Space Agency. It was flagged, isolated, and restricted to a small group with clearance. The source claims they are not trying to be a hero, they are not dying of cancer, and they are not LARPing, which is internet slang for live-action role-playing, pretending to be something you're not. They state these things explicitly because those are common accusations leveled against anonymous whistleblowers. They say they just feel that people need to know something big is about to happen. And then they add a timeline, December. Many at-home observers will see it all. December. That's when Atlas makes its closest approach to Earth. That's when it will be visible to amateur astronomers. With decent backyard telescopes, that's when the observation campaign of the International Asteroid Warning Network will be in full swing. That's when, according to this supposed insider, whatever is happening with this object will become undeniable, visible, observable by anyone with the equipment to look. Now, let's talk about credibility. This person is anonymous. They haven't provided their name or employee ID number, or any documentation that could convincingly prove that they work for the European Space Agency. The claims cannot be independently verified because the Fermi data that they are referencing has not been made public. There's no way to check if this gamma-ray signature actually exists. This could be an elaborate hoax. It could be someone with inside knowledge of the European Space Agency's procedures, using realistic jargon to spread disinformation. It could be a creative writing exercise that has gotten out of hand. But here's what makes it interesting: the very specific technical details, the precise terminology, the timeline that matches other observation patterns, and the claim that Fermi detected something unusual. This fits with the broader silence from official sources. The National Aeronautics and Space Administration still hasn't released the high-rise images from the Mars flyby. The European Space Agency has only released a few low-resolution frames from their orbiters, and these are the most powerful instruments we have. Training on this object and the highest quality data is being withheld if the Fermi telescope really detected an anomalous signal. That would explain the radio silence. That would explain why those Mars images were not made public. That would explain why the warning network, International Asteroid Network, activated so suddenly. The whistleblower said they have been monitoring online discussions. They mentioned checking platforms like Reddit, YouTube, and 4chan to see how the story develops. That could be someone who is actually trying to gauge the public's reaction to information they believe is being suppressed. Or it is someone who understands internet culture well enough to create a believable story. Either way, the impact has been significant. The post went viral. It has been screenshotted, analyzed, and debated in forums, and in comment sections all over the internet. So far, the space agencies have chosen to remain silent. The National Aeronautics and Space Administration has not commented. The European Space Agency has not released a statement. The Fermi collaboration has not published any data related to 3IAtlas. That silence is in itself significant. If the claims were obviously false, a simple denial would end the speculation. But when a seemingly credible source makes claims, with specific technical details about classified observations, and the response is complete silence, that tells you something. There is another layer to this. The whistleblower mentioned that the detection by Fermi was not shared or analyzed within the European Space Agency. That implies compartmentalization, information isolated from the broader scientific team. Only certain people with specific clearance are allowed to see it. That is not how scientific discoveries usually work. When a telescope detects something interesting, the data goes to the team that manages that instrument. They analyze it, they write it up, or they publish it. The process is transparent and collaborative. But when you are dealing with something that has national security implications or could cause public panic, normal protocols are suspended. Chapter 3. The Solar Flare and the Solar Anomaly That Just Hit It. While the Planetary Defense Network activated and whistleblowers were leaking claims of a technosignature, another development unfolded that no one predicted, except for one person. Geophysicist Stephen Burns, who had been tracking 3IAtlas since its discovery, posted something on October 21st that made even the skeptics pause. A massive coronal mass ejection had erupted from the far side of the Sun. Not a typical solar flare, not a minor geomagnetic disturbance, a halo coronal mass ejection, angled precisely in the direction 3IAtlas was traveling, and a direct hit was expected in 3 to 4 days, days before its perihelion. Burns announced it with unmistakable excitement. Boom shakalaka, bullseye, all in the kind of excited all caps that scientists rarely display in public. And then he added something even more remarkable. He had been accurately forecasting this exact scenario for months, not just predicting general solar activity, not just expecting the Sun to be active. During the solar maximum, he had specifically predicted that 3IAtlas would trigger a disruption. Electromagnetic forces in the inner solar system, and the closer it got, the more spectacular those disruptions would become. Now, on the day of the solar conjunction, when Comet Atlas was perfectly aligned on the opposite side of the Sun from Earth, a large coronal mass ejection erupted from the far side and was aimed directly at the comet. Let's break down what a coronal mass ejection actually is, because this term is often used casually, and most people don't grasp the sheer violence involved. The Sun's corona, its outer atmosphere, is held in place by magnetic fields that bend and twist as the Sun rotates. Sometimes those magnetic fields become unstable and they snap. When that happens, billions of tons of plasma, superheated gas, are launched into space at speeds ranging from hundreds to thousands of kilometers per second. That ejected material carries its own magnetic field, and when it slams into planets, spacecraft, or comets, it can trigger geomagnetic storms, auroras, and in extreme cases, damage to power systems and satellites. For Earth, coronal mass ejections are a known hazard. We have the protection of our magnetosphere. But powerful enough coronal mass ejections can still disrupt power grids and communications. For a comet, especially one that is outgassing and surrounded by a coma of gas and dust, the impact of a coronal mass ejection is transformative. The magnetic field carried by the coronal mass ejection interacts with the charged particles in the comet's coma. It can tear off a portion of the tail. It can compress the coma on one side and stretch it out on the other. And it can trigger a sudden brightening as the pressure of the solar wind skyrockets. And if the comet has any internal structure that responds to electromagnetic forces, a coronal mass ejection impact would be the ultimate stress test. Stephen Burns had been arguing for months that Comet Atlas wasn't just passively moving through the solar system. He believed it was actively altering the electromagnetic dynamics around it, that as the comet heated up and released more charged particles, it created a disturbance in the local electromagnetic environment, a ripple that spread outward and interacted with the Sun itself. In his model, Comet Atlas wasn't just another comet. It was a significant source of plasma and ions, and as it approached the Sun, it altered the magnetic field structure in ways that made solar eruptions more likely. This is not mainstream solar physics. Most scientists would say that the Sun's activity is driven by its internal dynamics, by the buildup and release of magnetic energy. in active regions on the Sun's surface. The idea that a comet, even a large interstellar comet, could influence solar activity from millions of kilometers away is considered fringe. But Burns had documented correlations. In August, when Comet Atlas was still far from the Sun, large eruptions occurred in the direction of the comet and Mars, eruptions that Burns had predicted, based on his model of electromagnetic interaction. And now, in October, at the time of the solar conjunction, when Comet Atlas was perfectly aligned behind the Sun, another eruption, another direct hit, another confirmation for his months-long forecast. The coronal mass ejection itself was extraordinary, described as originating from a far-side solar flare, possibly a double-digit X-class event. X-class flares are the most powerful type of solar flare. They release as much energy as billions of nuclear bombs. A double-digit X-class flare, something like an X10 or X20, is an event that only occurs once every decade. And according to Byrne, this eruption happened on the side of the Sun, that we cannot see from Earth, aimed directly at 3IAtlas as it passed through conjunction. We have no direct data on the flare that caused this coronal mass ejection. The far side of the Sun is invisible to Earth-based telescopes, and our solar observatories are positioned to track the Sun from Earth's perspective. But we can infer the magnitude of the flare from the structure and speed of the ejected material. Halo coronal mass ejections appear as an expanding ring of light from the Sun in coronagraph images and usually come from powerful flares. And the fact that the coronal mass ejection was skewed in the direction of 3IAtlas's motion suggests it was launched from a region on the far side that happened to align with the comet's trajectory. The timing could not be more critical. 3IAtlas reaches perihelion on October 29th. The impact of the coronal mass ejection is predicted for October 25th or 26th. That gives the comet about 3 days after impact to react before it reaches maximum solar heating and gravitational stress. If the coronal mass ejection is going to trigger any unusual behavior, any fragmentation, any orbital changes, any emission of secondary objects, it will happen in that window, and we won't see it. Earth-based telescopes cannot observe 3IAtlas during its solar conjunction. It's hidden behind the Sun's glare, the only spacecraft with any chance of observing. The aftermath are those positioned away from the Earth-Sun line, the Solar Orbiter and the Parker Solar Probe, and neither has publicly announced any observation plans for 3IAtlas. During this period, Byrne emphasizes that this is no coincidence. He has been forecasting this exact chain of events. Since early August, 3IAtlas approaches the Sun. Its plasma emission increases. The electromagnetic environment becomes unstable. Solar activity spikes, and eruptions occur in the direction of the comet. The closer 3IAtlas gets, the more intense the activity becomes. And now, at the crucial moment of solar conjunction, when the comet is perfectly aligned on the far side of the Sun, the largest eruption of the series launches and heads straight for it. There's a philosophical question embedded in this observation. Can a comet affect the Sun? Can a relatively small object, even one a few kilometers in diameter, alter the behavior of a star millions of times more massive? In conventional astrophysics, the answer is no. The Sun's magnetic fields and plasma dynamics are driven by processes deep within its interior. Surface phenomena like flares and coronal mass. Ejections are triggered by the buildup and release of magnetic energy in active regions. A passing comet should be like a mosquito flying past an elephant, insignificant, unnoticeable. But Byrne is proposing something more subtle. It's not that 3IAtlas is directly causing solar flares through gravitational or magnetic forces. That would be absurd. Instead, he is suggesting that the plasma and charged particles released by the comet create a pathway, a channel through which the sun's existing magnetic energy can be released more easily, much like how a lightning rod doesn't create lightning, but provides a preferential path for existing electrical potential energy to discharge. In this model, 3IAtlas doesn't power the flares, it triggers them. It provides the conditions that make eruptions more likely to occur in certain regions of the sun. There is a precedent for objects influencing plasma environments. Spacecraft moving through planetary magnetospheres often trigger electromagnetic waves and particle acceleration. Io, Jupiter's volcanic moon, plows into Jupiter's magnetosphere and powers some of the most intense auroras in the solar system. Comets passing near the sun can create disturbances in the solar wind that propagate outwards for millions of kilometers. The idea that a very large, very active interstellar comet could affect the local electromagnetic environment enough to influence solar dynamics is not impossible. It is just unproven, and it requires a level of activity from 3IAtlas that goes beyond what we typically see in comets. Byrne describes 3IAtlas as spouting water, not outgassing in the typical cometary sense. This spouting releases large amounts of water vapor at distances from the sun where most comets would still be frozen and inactive. This level of activity has been documented. Papers published in September noted that 3IAtlas is producing water at a rate described as a deluge, detectable at more than 3 astronomical units from the sun. That is unusual. Most comets don't become strongly active until they are much closer to the sun. Inside 2 astronomical units, 3IAtlas started spouting early and hasn't stopped. That amount of water vapor means a corresponding amount of ions. Water molecules in the solar wind are ionized, broken apart into hydrogen and oxygen ions. Those ions interact with the magnetic field. They form structures known as ion tails, which are invisible in normal light but detectable with specialized instruments. And if 3IAtlas is releasing as much water as observations suggest, then it is creating a giant cloud of ions around it, a cloud that stretches for millions of kilometers, a cloud that interacts with the solar wind, the sun's magnetic field, and anything else that passes through it. The impact of a coronal mass ejection would interact with that ion cloud. When the magnetic field of the coronal mass ejection collides with the comet's ion environment, you get what is known as magnetic draping. The solar wind's magnetic field wraps around the obstacle, creating complex structures and potentially accelerating particles to high energies. For an active comet like 3IAtlas, an impact from a coronal mass ejection could trigger a cascade of effects: sudden brightenings, tail disconnection events, changes in the emission spectrum, and if there is any solid structure within the comet's coma, any nucleus or artificial object, the electromagnetic forces could exert pressure, revealing its presence. Byrne does not claim 3IAtlas is artificial. He is not making the leap to alien spacecraft, but he is documenting extraordinary behavior, even for an interstellar comet. He is showing that this object is affecting its environment in detectable ways. Predictable, and unlike anything we have seen from previous visitors. Before and now, at the moment, 3IAtlas was most vulnerable, most active, most hidden from Earth's view. The sun fired a direct hit, 1 billion tons of plasma moving at 1,000 kilometers per second, aimed precisely where the comet would be in 3 days. What happened when they collided? We do not know. We could not observe it directly. The best we can do is monitor the aftermath when Atlas emerges from solar conjunction in November. We will see if it is still intact, if it is fragmented, or if its brightness has changed unexpectedly. We will see if its orbit has deviated from predictions. Those observations will tell us whether the impact of the coronal mass ejection was just another cometary interaction, or something more significant. Burns calls the correlation quite remarkable to see play out, which is a notable understatement. He had predicted months in advance that 3IAtlas would trigger solar activity during its approach. He specified that the activity would peak near perihelion. He had recorded the eruptions in August that supported his model. And now, on the day of the solar conjunction, the largest eruption of the sequence occurred, exactly as he had forecast. That was not luck. It is either a confirmed physical model or a series of coincidences so improbable that they demand an explanation. The electromagnetic interaction hypothesis has implications that go beyond solar activity. If 3IAtlas is truly altering the plasma environment around it, if it is creating disturbances that propagate through the solar wind, then it is doing something unusual. Natural comets affect their immediate surroundings, but the effects are localized and short-lived. What Burns is describing is a larger-scale interaction, a feedback loop between the comet's emissions and the sun's magnetic field, a relationship that forms over time and culminates in eruptions, coordinated at critical moments. And there is another layer to this. If the electromagnetic environment is being altered, if there are unusual plasma dynamics at play, then instruments like Fermi might detect anomalous signals. Gamma rays can be produced by particle acceleration in strong magnetic fields. If the impact of the coronal mass ejection created conditions where particles were accelerated to extremely high energies, you might see gamma ray emissions that would not occur under normal cometary conditions. That could explain the detection, attributed to Fermi. Not an engine, not artificial power generation, just an extraordinarily active comet in an extremely dynamic electromagnetic environment, creating emissions that mimic what you would expect from a technological source. Or perhaps both things are true. Perhaps 3IAtlas is artificially enhancing its own plasma output. Perhaps it is intentionally creating the conditions that trigger solar activity. Perhaps the impact of the coronal mass ejection was not an accident, but a calculated interaction. Perhaps the timing, the alignment, the precision of the eruption, all point to something more than natural processes. We are left with layers of possibilities, each of them plausible. Each model fits some of the data, yet none are confirmed. The step function burn will continue to be monitored. He has positioned himself as the only one who saw this coming, the one who predicted the solar activity, while everyone else was focusing on spectroscopy and orbital mechanics. If his model continues to hold up, if more eruptions occur as Comet Atlas approaches and leaves perihelion, then his voice will carry more weight. The extraterrestrial hypothesis will become harder to dismiss, and the question of what Comet Atlas truly is will become more urgent. The coronal mass ejection is in flight now, moving through space. At a speed of over 1 million kilometers per hour, it will reach Comet Atlas within a few days. The comet, hidden behind the sun, will bear the full force of the impact. And we will watch the sun. We will watch for more eruptions. We will watch for any sign that the electromagnetic dance between star and comet is continuing. And when Comet Atlas emerges into view in November, we will see what the impact has left behind. Chapter 4. Hidden Behind the Sun. The perfect cover. There is a window of time when anything could happen, and we would never see it. That window opens on October 21st and will not close until mid-November. During those weeks, Comet Atlas is positioned directly behind the sun from Earth's perspective, completely invisible to our telescopes, moving through the most critical phase of its journey. And this is not an accident of orbital mechanics. This is not random chance. The timing is too perfect. the alignment too precise. The solar conjunction happens to coincide exactly with perihelion, the moment the comet is closest to the Sun, moving at its fastest. Experiencing maximum gravitational and thermal stress is also the moment it is most hidden, most completely from observation. Avi Loeb has asked the question that everyone thinking about this trajectory had avoided. Was this hiding place planned? Was the timing of the solar conjunction and perihelion deliberately chosen? He frames it in the language of astronautics, of spacecraft design, of optimal trajectory planning, and the answer, from a purely engineering perspective, is if you wanted to perform a major maneuver without being observed, if you needed to change your course, or deploy secondary objects, or alter your configuration. You could not pick a better moment than perihelion during a solar conjunction. It is the ultimate blind spot. The Oberth effect is the basis for understanding why this timing is so critical in astronautics. When you want to change the trajectory of a spacecraft, you don't fire your engines just anywhere. You wait until you are moving fastest, until you are closest to the massive body that you are orbiting or passing. At that moment, a small amount of thrust produces the maximum change in kinetic energy. It's counterintuitive. You would think that it would be more efficient to burn your engines when you're moving slowly, but the math says otherwise. The faster you are moving when you apply thrust, the more dramatic the change in your final trajectory. For Comet Atlas, perihelion is that moment. On October 29th, it will be moving at about 68 kilometers per second, relative to the Sun. That is the fastest it will ever move in our solar system. That is when a propulsive burn, if one were to occur, would have the maximum effect. If you wanted to decelerate from interstellar speeds and enters a bound orbit around the Sun, this is when you would do it if you wanted to adjust your trajectory to intercept Earth at a later date. This is when you would set up that intercept if you wanted to separate into multiple objects that would follow slightly different paths. This is when you would initiate the separation. And all of this happens while it is unobservable from Earth. Our telescopes point towards the Sun every day, but we cannot look directly at it without specialized equipment. And even then, we can only see the Sun itself, not the objects hidden behind it. Ilias is not just behind the Sun, it is within the Sun's glare, the region where the Sun's brightness overwhelms everything around it, even if a telescope were pointed in the right direction. The light from the Sun would drown out any signal from the comet for about 4 weeks, from mid-October to mid-November. Ilias is completely invisible to Earth-based observation. The Sun's illumination at perihelion is staggering, with a minimum diameter of 5 kilometers. Ilias will receive over 33 gigawatts of solar power on its surface. 33 gigawatts. That's the output of 10 large power plants. That's enough energy to power entire cities. And all of that energy is being absorbed by the comet's surface, heating it, sublimating ice, and driving outgassing, potentially powering processes we haven't considered for a natural comet. That energy causes simple effects. Ice turns to vapor. Dust is lifted from the surface. The coma expands. The tail develops. The brightness increases. All predictable, all well understood. But if something more complex is happening, if there are any structures beneath the surface, any mechanisms that respond to the thermal input in non-standard ways, 33 gigawatts is enough to power it. Enough to run an engine, enough to generate thrust, enough to deploy secondary systems. Loeb points out that if Ilias maintains a trajectory shaped only by gravity, we should be able to track it after perihelion and confirm that nothing has changed. Its closest approach to Earth on October 19th, 2012, will occur exactly where models predict. The velocity will match. The brightness will match. Everything will be consistent with the natural comet hypothesis. But if anything deviates, if the trajectory shifts even slightly, if the arrival time at Earth is off by hours or days, if the brightness doesn't match the expected curve, then we will know something happened. During those hidden weeks, something altered the comet's path, something that cannot be explained by gravity alone. The idea of alien technology disguised as a natural comet appears in Loeb's essay, not as a definitive statement, but as a question, a hypothesis to be considered given the timing and circumstances. He notes that Halloween falls on October 31st, 2 days after perihelion, a symbolism not lost on anyone, the spookiest day of the year, and we are left to wonder if the interstellar visitor, currently hidden behind the sun, might be something other than what it seems. There is a deeper question embedded in all of this. Why would an advanced civilization design a spaceship to look like a comet? Why the need for camouflage? The most obvious answer is correct if you want to study a solar system without alerting its inhabitants. You don't arrive in a craft that is obviously artificial. You arrive in something that could plausibly be natural. An interstellar comet is perfect. It has a reason to be on a hyperbolic trajectory. It has a reason to approach the sun and pass through the inner system. It has a reason to outgas and be surrounded by a cometary coma that obscures any internal structure. From a distance, it looks exactly like what we would expect an interstellar comet to look like. Only up close, only with spectroscopy, detailed, and high-resolution imaging, do the anomalies become apparent. And if you're going to perform any actions that might reveal your artificial nature, you do them when you can't be observed. You wait for solar conjunction. You use the sun as cover. You make your adjustments, deploy your instruments, reconfigure your systems, all while hidden from the very civilization you are studying. Then you emerge on the other side, continue on your trajectory, and by the time anyone notices any discrepancies, you are past perihelion and moving away. Too late to intercept, too late to study closely, just late enough for the data to be ambiguous and the debate to go on forever. The European Space Agency's Ulysses spacecraft will pass within 64 million kilometers of 3IAtlas on November 4th. That's just after perihelion, after the comet has emerged from the worst of the sun's glare. But before it's fully visible from Earth, Ulysses has cameras, spectrometers, particle sensors. It wasn't designed to study comets, but it can point its instruments towards 3IAtlas and gather data. If the comet fragmented during perihelion, Ulysses might see the debris field. If the trajectory changed, Ulysses could measure the new path. If there are emission anomalies, Ulysses could detect them. This will be our first independent look at what happened during the hidden window. The United States National Aeronautics and Space Administration's Juno spacecraft will get a turn in March 2026, when 3IAtlas passes within 54 million kilometers of Jupiter. Juno has an ultraviolet spectrograph, an infrared imager, a microwave radiometer. It can analyze the comet's composition, search for thermal anomalies, detect any unusual emissions. By then, 3IAtlas will have been observable for months. We will have trajectory data from November and December. We will know if it behaved as predicted, or if something has changed. The Juno observations will add another layer of verification, another data set to compare against the models. But the critical moment is the October 29th perihelion, and we won't see it happen. We will infer it from the aftermath, from what 3IAtlas looks like when it emerges, from whether its trajectory matches predictions, from whether it's still a single object or is broken into pieces, from whether the spectral signature has changed, from whether new emissions have appeared that weren't there before. Loeb suggests watching the skies in November and December to look for any unusual activity or any new objects coming away from 3IAtlas. That wording is very specific. New objects, plural. The idea is that if 3IAtlas is a mothership, if it's carrying probes or smaller instruments, perihelion would be the optimal time to release them. Tidal forces from the Sun would then separate their orbits over the following months. By December, they would be far enough apart to be resolved as separate objects, not just part of a debris cloud. And if that happens, if telescopes begin to detect multiple objects in orbits that are slightly different, all originating from the same point during perihelion, the natural comet explanation would fall apart. However, natural comets are also capable of fragmenting. They can break apart when they get too close to the Sun. Thermal stress, outgassing pressure, and tidal forces all combine to pull the weakly bound material apart. The famous comet Shoemaker-Levy 9 fragmented into 21 pieces before colliding with Jupiter. Other comets have completely disintegrated during close passes to the Sun, leaving nothing behind but a cloud of debris. If 3IAtlas fragmented naturally, we would expect to see a characteristic pattern, a string of objects along the same orbit, a gradual separation over time, with no organized structure, no coordinated behavior. But if 3IAtlas intentionally released secondary objects, the pattern would be different. Controlled separation, velocity boosts, sending objects onto diverging paths, possibly different types of objects with different sizes and behaviors. That is the sign of intelligent action versus random disintegration. And December is when we will begin to see the pattern emerge, when the separation between the objects becomes large enough to measure, when independent observers can track multiple targets and calculate their individual orbits. The choice of October 19th for the closest Earth approach is also very interesting. That date is not random. It falls at a time of year when the northern hemisphere has long nights and the sky is relatively clear in many locations. Amateur astronomers will have extended observation windows. Telescopes in both hemispheres can track the comet, and 3IAtlas will be in the constellation Virgo, a constellation well positioned for observation in the pre-dawn sky. If something unusual is about to become visible, December is the month when the most people will be watching, with the most time to collect data. He concludes his essay with a call for evidence-based science, not expectation, not assumption. The data from November and December will tell us whether 3IAtlas is maintaining a gravitational orbit or if something else has happened. We do not need to speculate. We need to observe, measure, and analyze. The universe will provide the answer if we pay attention, but the timing still haunts the analysis. Solar conjunction during perihelion, an optimal maneuvering window during optimal concealment, maximum solar energy input. During maximum invisibility, it is the perfect setup for a covert operation, and whether that perfection is coincidence or design is the question that will determine how we interpret everything that happens next. If 3IAtlas emerges unchanged on its predicted path, showing no anomalies, then the coincidence remains remarkable, but ultimately meaningless. Just another case of humans seeing patterns where there are none. But if anything else happens, if there are any deviations, any new objects, any unexplained emissions, then the coincidence becomes evidence. Evidence that the timing was not random, that the trajectory was not an accident, that 3IAtlas knew exactly when and where to make its move, and that we are only just beginning to understand what we are truly dealing with. The sun provided the perfect cover. The question is whether anyone was using it. Chapter 5. The mystery of the alien industrial alloy. The spectral data should have been simple. The telescope and a comet, measuring the light from its coma to determine which elements are present. Based on their emission lines, for solar system comets, the results are predictable. Water vapor, carbon dioxide, dust, traces of metals like sodium and iron, usually in small amounts, are released as the nucleus warms up. Nothing controversial, nothing to rewrite the textbooks. But Atlas did not follow that script. When the Keck 2 telescope in Hawaii analyzed the comet on August 24th, it detected something that shouldn't exist in nature: nickel without iron. And not just trace amounts. 4 grams of nickel per second were flowing out of the object, with no detectable iron accompanying it. That ratio is wrong, cosmically wrong, in every natural environment we have ever studied. Nickel and iron appear together. They are created together in the process of stellar nucleosynthesis. They condense together in protoplanetary disks. They are chemically similar, with nearly identical properties. So they behave the same way in geological and thermal processes. When you find one, you always find the other, except in Atlas, where nickel was abundant and iron was absent. Avi Loeb did not mince words when he saw the data. There is only one place where that is known to exist, and that is in industrially produced nickel alloys. He mentioned a specific compound, nickel tetracarbonyl, a chemical that forms when nickel reacts with carbon monoxide under specific conditions. Those conditions do not occur naturally in comets. They occur in human manufacturing facilities, in processes designed to refine nickel or coat surfaces with nickel plating. It is an industrial chemical, product of intentional engineering, and according to the spectroscopic data, Atlas was producing it by the kilogram. Nickel tetracarbonyl has a very specific use in technology. It is part of the Mond process, a technique for refining nickel to extremely high purity. You start with impure nickel ore. You expose it to carbon monoxide at a moderate temperature. The nickel forms a gaseous compound, nickel tetracarbonyl, which you can then separate from the impurities. Heat it again, and the compound decomposes, depositing pure nickel metal. It's elegant, efficient, and uniquely suited for industrial applications, where you need very pure nickel, such as in aerospace alloys, electronic components, or surface coatings for equipment that must withstand extreme conditions. The aerospace connection is not subtle. Nickel-based superalloys are used in rocket engines, in spacecraft structures, in anything that needs to resist high temperatures and mechanical stress. They are essential for advanced propulsion systems. And now we have an interstellar object, emitting a nickel compound primarily known from industrial refining and aerospace manufacturing processes. The implications are uncomfortable. Either we are witnessing a natural process that mimics industrial chemistry so closely that it produces the exact same compounds, or we are witnessing actual industrial chemistry happening on an object that should be a frozen ball of ice and rock. The Keck data also showed another anomaly. The emission profiles of both nickel and cyanide around Atlas were asymmetrical, with an extension in both the sunward and anti-sunward directions. That creates what astronomers call an anti-tail, a structure that seems to point toward the sun instead of away from it. A normal comet tail points away from the sun because solar radiation pressure pushes dust and gas outward. An anti-tail suggests internal activity, pressure from within the material-filled nucleus in multiple directions, not just the one dictated by the solar wind. That kind of activity requires energy. A lot of energy, much more than you would expect from simple ice sublimation. The production rate of nickel compared to cyanide was several orders of magnitude higher than the median for solar system comets. Several orders of magnitude. That means not just a little higher, not twice or 5 times, but hundreds or thousands of times more nickel than any known comet produces. And cyanide itself is very interesting because it indicates organic chemistry, carbon-nitrogen bonds, the building blocks of more complex molecules. Combined with the nickel emission, you have a chemical environment that is simultaneously organic and metallic. Prebiotic precursors mixed with industrial compounds. It is a strange combination, not impossible, but profoundly unusual. Researchers from the Atlas Observatory noted that, while this phenomenon is rare, a new study suggests it might be natural. That word, might, is doing a lot of work in that sentence. It does not say that the process is understood. It does not say there is a clear natural mechanism that explains the observations. It is saying that they have not yet ruled out natural explanations. That is a very different statement. Science operates on the principle that you exhaust all mundane possibilities before resorting to the extraordinary. But when the mundane possibilities require new chemistry that has never been observed in any other comet, you have to ask how far you stretch the definition of mundane. The absence of iron is particularly concerning. Iron is one of the most abundant elements in the universe. It is a major component of rocky bodies, metallic asteroids, and planetary cores. In comets, iron appears alongside nickel because both were incorporated into the comet during its formation. The fact that Comet Atlas shows strong nickel emission but no corresponding iron suggests either extreme fractionation during formation, which would require very specific and unlikely conditions, or an active separation of nickel from iron, which would require a preferential process of releasing one element while retaining the other in an industrial setting. That separation is precisely what nickel refining does, by extracting pure nickel by converting it into a compound that can be isolated from iron and other impurities. If Atlas were a spacecraft, if it had nickel-based structural components or a surface coating, thermal stress during its solar approach could cause the outgassing of the nickel and carbon compounds needed to form nickel tetracarbonyl. The carbon could come from organic matter on the surface, or from the decomposition of more complex carbon-bearing molecules. The heat from the sun provides the energy. The chemistry occurs spontaneously once the conditions are right. And what you see from Earth is exactly what the Atlas telescope detected: abundant nickel with no iron, a chemical signature that matches industrial processes. But this is where it gets more complicated. The Very Large Telescope in Chile, using its UVES spectrograph, obtained additional data in early October. While that observation confirmed the anomalous nickel-to-iron ratio, they also noted that the presence of nickel atoms and iron in cometary spectra in general is unexpected, because the surface temperature is too low for them to sublimate. Refractory minerals. Refractory means a high melting point. The metals nickel and iron should not have vaporized at the distances where Atlas was showing these emissions. The comet would need to be much hotter, or there would need to be another mechanism releasing the metals. One possibility is impact ejection, where small particles collide and break apart, releasing atoms into the coma. Another possibility is photolysis, where ultraviolet light from the sun breaks apart molecules containing the metals, but those processes should have released iron and nickel together, not separately. The fact that iron was missing, or at least undetectable, points to something more selective happening, something that preferentially mobilizes nickel. The anti-tail is another piece of the puzzle. A normal comet tail is pushed away from the sun by radiation pressure in the solar wind, but Atlas had a stream of material, visible at multiple wavelengths, stretching towards the sun. The explanation offered in the papers is that large dust particles, too heavy to be, blown back by radiation pressure, are ejected by internal activity and follow a ballistic trajectory. Some of those trajectories, depending on the ejection velocity and angle, can create the illusion of an anti-tail when viewed from Earth. It's a geometric projection effect. Except Atlas had emissions of nickel and cyanogen in the anti-tail. Not just dust. Gas molecules light enough to be affected by radiation pressure, were somehow still appearing in the sunward direction. That requires active ejection. Jets of gas and dust coming from the nucleus with enough velocity to overcome solar pressure, at least temporarily. And jets require pressure. They require venting. They require a mechanism that builds up pressure beneath the surface and releases it suddenly. That can happen naturally in comets when pockets of volatile ices sublimate rapidly. But the symmetry of the emissions, the consistency, the fact that it was happening across multiple wavelengths, all suggest something more organized than random outgassing. Loeb described the situation as a comet that doesn't show a cometary tail, and its orbit is finely tuned to align with the orbital plane of the Sun's planets. He wrote, "Insisting that Atlas must be a comet is unwise because it does not behave like one." And he's not wrong. The white light images of Atlas don't show a familiar cometary tail. There's a coma. There's some diffuse structure, but the long, sweeping dust tail we associate with bright comets is either absent or extremely faint. For an object this large, this active, this close to the sun, you would expect a dramatic tail. Instead, you get ambiguity, hard-to-interpret structure, emissions that don't fit the standard model. The chemical fingerprint is the strongest anomaly. Nickel tetracarbonyl does not occur in nature. It's a human invention, a compound we synthesize for specific industrial purposes. Finding it, or something spectrally indistinguishable from it, in the coma of an interstellar comet means either we've discovered a new, independent natural process that produces the same compound through entirely different chemistry, or we're looking at the residue of industrial activity. Occam's razor would normally favor the natural explanation. The universe is vast. Strange chemistry happens. But when the strange chemistry produces the exact compounds used in aerospace manufacturing, and those compounds appear on an object with many other anomalies, the razor begins to cut in the other direction. There is also the issue of scale. 4 grams of nickel per second for weeks or months, that adds up to tons of material. Where does it come from? How much nickel does Comet Atlas contain if it is a natural comet? Nickel would be a trace element locked in mineral grains, released slowly as the nucleus erodes. You would not expect kilograms of nickel at over the entire active life of a comet, let alone grams per second. If it is artificial, if there are nickel alloy structures inside the object, then the outgassing makes more sense. Surface coatings, structural components, heat shields, and all could release nickel compounds under thermal stress, and the amounts could be significant if the structures are large. The researchers working on this data are very careful. They do not claim that Atlas is artificial. They document the anomalies. They note the unusual ratios. They suggest that natural processes might explain it, but they do not provide a detailed mechanism. They do not explain how a comet produces industrial-grade nickel compounds without also producing iron. They leave that question open. And in science, an open question is an invitation to propose alternatives, to test hypotheses, to push the boundaries of what we consider possible. The nickel production will continue as Atlas moves through perihelion, if anything. It might intensify as the comet gets closer to the sun and the temperature rises. Ulysses and Juno will both have spectrometers. yet capable of analyzing the emissions. We will get more data, better resolution, longer observation times, and we will see if the nickel-to-iron ratio holds, whether it changes, whether new compounds appear. Each measurement will either reinforce the anomaly or provide a path to explain it naturally. But right now, today, based on what the Keck telescope and the Very Large Telescope have shown us, Comet Atlas is emitting a chemical that should not exist in a comet, a chemical synonymous with industrial nickel processing, a chemical that appears in aerospace alloys and surface treatments, a chemical that requires specific conditions to form, conditions not normally found in the cold vacuum of space, unless someone built something and left it there, unless we are looking at the exhaust, and from a manufacturing process that happened light years away, and is now outgassing into our solar system as the structure heats up and degrades. The alternative is that the universe is stranger than we think, that cometary chemistry is more diverse than our models predict, that nickel tetracarbonyl forms naturally, under conditions we have not yet identified, that Comet Atlas is simply the first example of a new class, and of interstellar comet with a strange composition and unusual thermal behavior, that everything is natural, just unexpected. That explanation is possible. It is even likely from a statistical standpoint, but it requires us to accept that a visitor from another star independently evolved chemistry that mimics human industrial processes, and that this coincidence, this perfect alignment between what we create and what nature produces, is just that, became harder to accept with each new data point. This October 30th consciousness event, while scientists debated nickel ratios and orbital mechanics, another story emerged from an unexpected direction, not from observatories or academic papers, but from social media, from a viral video in mid-October, claiming that October 30th, 2025, precisely at 11:44 Coordinated Universal Time, would mark a global consciousness shift, not in a metaphorical sense, but in a literal one, an electromagnetic event triggered by the convergence of three cosmic phenomena: the Sun at solar maximum, Comet Atlas reaching perihelion, and Earth's magnetic field at its weakest point in many decades. According to the video, these three factors would combine to amplify Earth's natural frequency, the Schumann resonance, to levels unseen in recorded history. And when that happened, 6.2 billion people, about 76% of humanity, would experience neural synchronization simultaneously, a planetary awakening, a consciousness event. The video was polished, well-produced. The speaker presented complex ideas with confidence, using scientific terminology mixed with spiritual concepts. He spoke of the Schumann resonance as the Earth's heartbeat. At 7.83 Hertz, the frequency at which the space between the Earth's surface and the ionosphere naturally resonates, driven by lightning around the planet. He explained that this frequency matches the range of brain waves, known as theta, a state associated with deep meditation, creativity, and altered consciousness. The implication was that the Earth and the human brain are naturally tuned to the same frequency, that we are literally in sync with the planet's electromagnetic field. Then he introduced the trigger for October 30th, three major events converging. First, the Sun at solar maximum, more active than in 25 years, with solar flares, coronal mass ejections, magnetic pole reversals, and all the other phenomena. Second, Comet Atlas reaching its closest point to the Sun, a city-sized object from another star system, glowing, outgassing, and interacting with the solar wind in ways we are still trying to understand. Third, Earth's magnetic field at its absolute weakest point in the current cycle. The protective shield that normally buffers us from solar radiation and cosmic rays is thinner than usual, more permeable, more susceptible to external influences. When these three factors hit at the same time, the video claims, the Earth's frequency will be amplified 10 times or more. Instead of 7.83 Hz, you're looking at 78 Hz or higher, hitting your brain, and the human brain will have no choice but to synchronize. That's just how entrainment works. It's neuroscience. When an external frequency is strong enough, neural oscillations will adjust to match it. Your brain waves lock onto the external signal. You can't fight it, you can't ignore it. Your neurons fire, in rhythm with the planetary field, and your consciousness shifts into a state you've never experienced before. The math presented in the video was seductive. Research shows you need the square root of 1% of the population to create global change. For 8 billion people, that's 90,000 minds synchronized at once. But with this electromagnetic disruption, we're looking at 2 billion people synchronizing simultaneously. That's 22,000 times what you need for critical mass. The mathematics of consciousness. The video explained. Saying this would create a global field effect, a resonance that would propagate through the entire human population, pulling more and more people into coherence, until the synchronization becomes self-sustaining. Then comes the analysis of brainwaves. Normal consciousness operates at around 20 Hz. Beta waves are your daily state of thinking, planning, and problem-solving. But when the Earth's frequency surges, your brain will reach a bandwidth of 100 Hz or more. You access gamma waves, 40 Hz, 80 Hz, 200 Hz. These are frequencies associated with higher consciousness, enlightenment, peak performance, even psychic abilities, states that meditators spend years trying to achieve, states that mystics describe as transcendent. And on October 30th, according to this theory, 6.2 billion people will experience those states simultaneously, whether they are ready or not. The numbers keep coming. Of that 6.2 billion, 365 million have a natural electromagnetic sensitivity. Those who already feel the shifts during solar storms and geomagnetic disturbances, for them, the effect will be the strongest. And 43 million people, the video predicts, will achieve a truly transcendent state during the peak hours. Full-blown mystical experience. The dissolution of the ego, a unified consciousness. The kind of experience that has historically been rare, personal, and life-changing. Except this time, tens of millions of people will have them at the same time. The peak moment is specified down to the minute. 11:44 a.m. Coordinated Universal Time on October 30th, 2025. That is when Comet Atlas reaches its perihelion. That is when the electromagnetic alignment is perfect. But the effects build up for hours before and after, from 6 a.m. to 6 p.m., Coordinated Universal Time. You are looking at 12 hours of peak electromagnetic disruption. 12 hours where the Schumann resonance is amplified, where solar activity is intense, where the magnetic field fluctuates wildly. 12 hours of exposure to frequencies that the human brain is not evolutionarily prepared to handle. And then comes the warning. Technology will have a bad day. Global positioning systems could go down for 12 hours or more. Power grids will be strained, and communication networks will be disrupted. The same electromagnetic forces that elevate human consciousness will wreak havoc on electronic systems. As the video suggests, it's as if the universe is telling us to disconnect from our devices and reconnect with each other and our inner awareness. While technology fails, human consciousness soars. The preparation guidelines are simple. Start meditating daily. even for just 10 minutes, to help your brain adapt to the frequency shift. Spend time in nature to ground your electrical system. Stock up on essential supplies. In case of technological failure on the day, the scenario is both reassuring and ominous. Reassuring, because it offers concrete steps you can take. Ominous, because it implies that if you are not prepared, the experience could be overwhelming. That 6 billion people suddenly experiencing altered states of consciousness could lead to confusion, panic, or social disruption if no one is ready. The science cited in the video is real, to a degree. The Schumann resonance is a documented phenomenon. Brainwave entrainment is well researched. Solar activity does affect Earth's magnetic field, but the connections drawn between these phenomena and a global consciousness shift require leaps of faith that mainstream science does not support. There is no evidence to suggest that a temporary spike in the Schumann resonance, even a tenfold increase, would synchronize billions of brains. There is no known mechanism by which Comet Atlas, from over 200 million kilometers away, could directly affect Earth's magnetic field in the way described and predicted. 43 million transcendent experiences occurring simultaneously, not based on any peer-reviewed research. However, the video resonated. It has millions of views. The comments a mixture of excitement and skepticism, personal testimonies, and requests for more information. Some people reported feeling unusual energy, heightened intuition, and vivid dreams. Others dismissed it as pseudoscience, as fear-mongering, designed to exploit people's anxieties about solar activity and interstellar visitors. But a significant portion of viewers took it seriously. They planned. They prepared. They waited for October 30th with a mix of hope and anxiety. The connection to Comet Atlas was clear. The video described the comet as a catalyst, not the sole cause, but an essential component of the electromagnetic alignment, an interstellar object carrying its own energetic signature, interacting with the sun's magnetic field, contributing to the amplification of planetary frequencies. Whether that interaction was natural or intentional was left ambiguous. The video did not claim Comet Atlas was artificial. It did not invoke extraterrestrial intelligence, but it treated the comet as more than just a rock and ice, as a participant in cosmic events, as something significant for the evolution of human consciousness. There's an older tradition that this taps into, the idea that comets are omens, heralding change. In ancient cultures, comets signaled the death of kings, the rise of empires, the beginning of new eras. Astronomy has stripped away the mysticism. Comets are just icy debris, leftovers from planetary formation. Nothing special, nothing meaningful. But the symbolic power remains. When an interstellar comet appears, when it behaves strangely, when it arrives at a time of uncertainty and technological upheaval, people search for meaning. They ask if the universe is trying to tell us something. The prediction for October 30th is testable. Either the electromagnetic disruption happens, or it doesn't. Either global positioning fails, power grids falter, and communication systems malfunction, or they don't. Either millions of people report unusual experiences, altered states, heightened awareness, or they don't. By November 1st, we will have data, we will have reports from around the world. We will know if October 30th was just another day, or if something truly anomalous occurred. But there is a more subtle aspect to this theory. Even if the electromagnetic predictions are overblown, even if nothing measurable happens to the Earth's magnetic field or the Schumann resonance, the collective expectation itself creates an effect. 6 million people, tens of millions of people, all focused on the same moment, all expecting a shift, all primed to notice changes in their own consciousness. That collective attention is a form of synchronization, not electromagnetic, but psychosocial and cultural. When enough people expect something to happen, their behavior changes. They pay more attention. They interpret ambiguous experiences through the lens of expectation. They connect with others who share the anticipation, and the result can feel like a collective event. Even if the underlying mechanism is entirely human. The video ends with a declaration. October 30th, 2025, will be a day humanity remembers as the day we evolved, not gradually over millennia, but together, consciously, in a single day. It is a bold claim, a claim that will either be proven or forgotten within a few weeks, but for now, it adds another layer to the story of 3IAtlas, another way this object has captured the imagination. It's sparking theories and forcing people to consider possibilities they would normally dismiss. 45 days to prepare, the video said. 45 days until the most significant consciousness event in history. The math says you will never be the same. And whether that claim is rooted in electromagnetic reality or collective mythology, it has changed how millions of people are thinking about October 30th. They are watching the sun. They are watching 3IAtlas. They are waiting to see if the universe will deliver on a promise that no scientist ever made. But that resonates deep within the psyche, the part of us that still looks to the heavens for signs and wonders. The Schumann resonance has been measured continuously since the 1960s. It fluctuates slightly based on solar activity, seasonal changes, and lightning distribution, but it remains stable around 7.83 Hz. A sudden, dramatic spike. To 10 times that value has never been recorded. If such a spike were to occur on October 30th, it would be scientifically unprecedented. It would demand an explanation. And if it happened to coincide precisely with 3IAtlas reaching its perihelion, the coincidence would become almost impossible to ignore. Geomagnetic observatories around the world monitor Earth's magnetic field in real time. The data is public. Anyone can check to see if there is any unusual activity on October 30th. Solar observatories track coronal mass ejections, solar flares, and solar wind conditions. Space weather forecasting is routine. We will know if October 30th brings exceptional solar activity or if it's an average day. The electromagnetic hypothesis is falsifiable. It makes predictions that can be tested, and in a landscape filled with vague spiritual claims that can never be disproven, its specificity is refreshing. What happens if the predictions are right? If October 30th brings widespread technological disruption, if GPS satellites lose their lock, if power grids experience unexplained fluctuations, if millions of people report altered states of consciousness, what then do we attribute it to 3IAtlas? To solar activity? To Earth's magnetic field? Or do we start asking if something about this interstellar visitor is more interactive than we assumed? If its electromagnetic signature, natural or not, has a real effect on systems we thought were isolated? The consciousness shift theory is easy to dismiss. It blends science and spirituality in ways that make academics uncomfortable. It makes testable predictions based on mechanisms that are not well established. It appeals to people who are searching for meaning, for transformation, for proof that we are on the verge of something extraordinary. But dismissal is not the same as debunking. And until October 30th has passed, until we see what actually happens, the theory remains a possibility. A strange, unlikely, uncomfortable possibility that an interstellar comet could be the catalyst for something that goes far beyond orbital mechanics and spectroscopy, something that touches consciousness itself. What are the anomalies scientists can't explain? Let's step back from the predictions and the prophecies and look at what is on the record, what has been measured, peer-reviewed, and published in scientific journals. Because even without resorting to alien technology or consciousness shifts, 3IAtlas presents a constellation of anomalies that, when combined, make it unlike any object we have ever encountered. 8 distinct characteristics that do not fit comfortably within the framework of a natural comet. Each one could potentially be explained individually, but for all 8 to occur in the same object, that pattern demands unusual attention. Anomaly 1, ecliptic alignment. 3IAtlas moves within 5 degrees of the ecliptic plane, the flat disk where Earth and the other planets orbit. For an interstellar object arriving from a random direction in the galaxy, this is statistically improbable. Interstellar space is 3-dimensional. Objects can arrive from any angle. The probability of an interstellar comet happening to align so closely with our planetary system's orbital plane is less than 1%, perhaps less than a fraction of 1%, depending on how you calculate the probabilities. Previous interstellar visitors, Oumuamua and Borisov, arrived with inclinations of 123 degrees and 44 degrees, respectively. They were significantly inclined relative to the ecliptic. 3IAtlas, however, is nearly flat, almost perfectly aligned. It is as if it chose an orbit that would bring it close to multiple planets without requiring unusual, steep inclination changes. Anomaly 2 as the anti-tail. A comet's tail always points away from the sun. Solar radiation pressure and the solar wind push gas and dust outward, creating the characteristic tail that flows behind the comet as it moves. But 3IAtlas has a structure that appears to extend toward the sun. Images from multiple telescopes show emission in both the sunward and anti-sunward directions. The proposed explanation is that large dust particles are ejected with enough velocity to travel sunward before radiation pressure takes over, a ballistic trajectory effect. But that explanation requires very specific ejection speeds and angles. It requires sustained directional outgassing. It requires internal pressure sources strong enough to overcome solar radiation forces. Natural comets can produce jets of gas, but they are typically localized and transient. 3IAtlas shows an opposing tail structure that is persistent across multiple wavelengths. That level of organization is unusual. Anomaly 3 size, with a minimum diameter of 5 kilometers and potentially up to 20 kilometers, depending on albedo assumptions. 3IAtlas is enormous. Oumuamua was estimated to be only hundreds of meters, and Borisov, at most, a few kilometers. 3IAtlas is larger than any interstellar object we have detected. That size has implications. Larger objects are rarer. They require more mass to be ejected from their parent star systems. They are harder to accelerate to interstellar speeds. The fact that we have only detected 3 interstellar visitors, and the third one is the largest, suggests either we are very lucky, or that large interstellar objects are more common than our models predict, or that the size is not random. If 3IAtlas were artificial, if it were designed for interstellar travel, its large size would make sense, providing more room for fuel, equipment, and shielding, and a more robust structure for a journey lasting thousands or millions of years. Anomaly 4 planetary flyby trajectory. 3IAtlas didn't just pass through the solar system on a random path. It came close to Mars, Venus, and Jupiter, close enough for spacecraft at those planets to observe it, and close enough that its trajectory brought it near. Multiple targets of scientific interest. For a natural object, this is another low-probability event. Most interstellar trajectories would miss the planets entirely, or pass close to only one. 3IAtlas cut right through the inner solar system in a way that maximizes the opportunity for observation from many vantage points. That could be a coincidence, or it could be the targeting of a precise trajectory designed to collect 10 data points about several worlds in a single pass. Anomaly 5, nickel enrichment. The ratio of nickel to iron is wrong, very wrong, many orders of magnitude higher than in any known comet. The detection of nickel tetracarbonyl, or a spectrally similar compound, raises questions of industrial chemistry. Natural processes that concentrate nickel while depleting iron are rare and require very specific conditions. The fact that this is occurring in an interstellar comet, an object that should have a composition reflecting the average abundance in its formation region, is very puzzling. Either Atlas formed in a place with intensely anomalous chemistry, or something is selectively releasing nickel from the object. Something like the thermal degradation of structures with nickel alloys. Anomaly 6, water content. Most comets have about 80% water ice. Atlas has about 4% water. The majority of its volatile component is carbon dioxide, or dry ice, which makes it an unusual comet, even by solar system standards, and extremely unusual for an object from another star. The ratio suggests formation in a very cold environment, far from any star, where carbon dioxide can condense, but water is still too volatile to be retained. Or it suggests that the water was depleted over time, either through prolonged exposure to interstellar radiation, or through processes that preferentially remove water while retaining carbon dioxide. The implications for where Atlas came from and how old it is are significant. An object with that composition could be billions of years older than our solar system, or it could have lost most of its water during a long, active journey through the galaxy. Anomaly 7, extreme negative polarization. When light scatters off particles, it becomes polarized. The degree and direction of polarization tell you about the size, shape, and composition of the particles. Atlas shows negative polarization values that are unprecedented among comets. Even Borisov, which was unusual in its own right, did not show this extreme polarization. Negative polarization suggests particles with very specific properties, possibly including metallic or crystalline structures that scatter light differently than the fluffy aggregates found in the dust of a HSA. Typical comet. This is another piece of evidence that the material around Atlas is not ordinary cometary dust. It is something more organized, more structured, and potentially more processed. Anomaly 8. Direction of arrival. Atlas came from a direction within 9 degrees of the source of the WOW signal. The WOW signal was detected in 1977. It is the most famous candidate for an extraterrestrial radio transmission. It was a narrow-band signal, strong, at a frequency consistent with intentional communication. It lasted for 72 seconds and was never detected again, despite repeated searches. The source direction is in the constellation Sagittarius, near the galactic center. Atlas came from almost the same direction. That could be a pure coincidence. The constellation Sagittarius covers a large area of the sky. Millions of stars lie in that region. But the correlation is not dismissed. If an advanced civilization sent a radio signal toward Earth in 1977, and then sent a physical probe many decades later, both would arrive from nearly the same direction in the sky. The timing would be tight. The signal's travel time at the speed of light would be 48 years. A slower-moving probe would take longer. The math doesn't quite add up, unless the probe left much earlier. But the symbolism is powerful. The most famous potential alien signal and the most anomalous interstellar object, both from the same region of space. These 8 anomalies don't prove BAY-Atlas is artificial, each one considered in isolation, can be rationalized. The zodiacal alignment, Low probability, but not impossible. The lack of a tail. Complex, outgassing dynamics, its large size. We have only detected a few interstellar objects. So, our sample is biased. The planetary orbit, a coincidence. The unusual chemical enrichment of nickel. Low water, a cold formation environment. Negative polarization. Unique dust properties. The direction of the wow signal. The Sagittarius constellation is a large area. Any one of those explanations holds up, but all 8 of them together. That is the challenge. The cumulative improbability, the layering of anomaly upon anomaly, until the natural explanations begin to feel strained. This is where the LOP scale comes in. The LOP scale is a proposed framework for evaluating the likelihood an object has a technological origin. It ranges from 1 to 10. 1 means it's perfectly consistent with natural phenomena. 10 means it's unmistakable evidence of technology. 3IAtlas is rated a 4. Anomalous, but not conclusive. It has enough anomalies to warrant serious investigation, but not enough to definitively rule out a natural origin. A rating of 4 means continue monitoring, continue gathering data, not rushing to conclusions, but also not dismissing the possibility. The possibility of a rating of 4 is important, because it justifies the response we are seeing, the activation of the International Asteroid Warning Network. Coordinated observation campaigns. The mobilization of resources to track this object through December and beyond. A rating of 1 or 2 would not have deserved that response. An 8 or 9 would trigger a very different kind of response, likely involving classified briefings and emergency protocols. 4 is the sweet spot, interesting enough to prioritize, ambiguous enough to maintain public calm, strange enough to keep scientists engaged and searching for more data. Every future observation has the potential to move BAY-Atlas up or down the scale. If user detects more anomalies in November, if amateur observers see unexplained structures in December, if Juno finds emissions inconsistent with a natural comet in March, the rating will go up. If everything aligns with natural models, if the trajectory remains purely gravitational, if the chemistry resolves into known processes, the rating will go down. The scale is dynamic. It responds to evidence. And right now, we are in the phase where evidence is still accumulating. Consider what happens if even 1 more major anomaly is confirmed. If the alleged Fermi gamma-ray detection is verified. If the whistleblower claims about engine-like sounds are substantiated. If the impact of the coronal mass ejection produces effects inconsistent with the cometary response, any of those would push BAY-Atlas to a 5 or 6 on the scale. And at that point, the conversation would change. Media coverage would increase dramatically. As funding for observation campaigns grew, the possibility of it being technology ceased to be a fringe hypothesis and became a mainstream debate. The 8 anomalies also accumulated in another sense. They interacted with each other. The zodiacal alignment made the planetary flyby trajectory more significant, while the nickel enrichment, combined with the anti-tail, suggested internal activity, beyond simple sublimation. The low water content and extreme negative polarization all pointed to unusual material properties. The direction of origin from the Sagittarius constellation carries weight when combined with all the other oddities. You cannot isolate the anomalies and evaluate them independently. They form a pattern, and patterns, especially those that align with hypotheses of artificial objects, are what scientists look for when trying to distinguish signal from noise. There is an intellectual honesty in rating BA-Atlas as a 4. It acknowledges the anomalies without claiming certainty. It says that we don't know what this is, and we need more information before making definitive statements. That stance is appropriate. Science progresses by accumulating evidence, not by rushing to conclusions, but it also means we are in a state of limbo, in a state of uncertainty that will last for weeks or months, until the next round of data arrives. And in that limbo, speculation thrives, and theories multiply. People fill the void with their own interpretations, their own hopes or fears about what 3IAtlas might represent. The 8 anomalies are documented. They are in the scientific literature. They are not rumors or leaks. They are measurements. And measurements do not care about our preferences. They do not adjust themselves to fit comfortable narratives. They simply are what they are. And what they are, collectively, is a challenge to our assumptions about interstellar objects, about cometary behavior, about what should and should not be possible in the natural universe. Whether that challenge leads to a new understanding of cometary physics, or to the first confirmed detection of extraterrestrial technology, is the question the next few months will begin to answer. So what happened from November to December? The wait was nearly over. After weeks of 3IAtlas being hidden behind the sun, after its unobserved perihelion passage, after all the speculation about what might have happened in that blind window, we finally had answers. The timeline is very precise. On November 4th, a Jupiter-bound spacecraft passed within 64 million kilometers and pointed its instruments toward the comet. In mid-November, 3IAtlas emerged from its solar conjunction and became visible again to Earth-based telescopes. In late November, the observation campaign of the International Asteroid Warning Network officially began. On December 19th, it made its closest approach to Earth at a distance of 269 million kilometers. And throughout that entire period, hundreds of professional and amateur telescopes would be tracking it, collecting data, looking for any deviation from the predicted behavior of a natural comet. JUICE was the first observer, the Jupiter Icy Moons Explorer, a spacecraft designed to study the moons of Jupiter, namely Europa, Ganymede, and Callisto. It was launched in 2023 and is currently on a complex trajectory, involving multiple flybys of Earth and Venus to build up the necessary speed to reach Jupiter on November 4th, 2025. It happened to be in the right place at the right time to observe 3IAtlas just a few days after its perihelion. This was not a target for the planned mission. USER was not designed to study comets, but the opportunity presented itself, and the European Space Agency is seizing it. USER carries the DANIS camera, a visible light imaging system, Magister, an infrared spectrometer, SV, a millimeter wave instrument capable of detecting gas composition. Together, these instruments can provide a comprehensive view of 3IAtlas in its post-perihelion state. If the comet fragmented, DANIS will see the debris field. If the chemical composition changes, Magister will detect it. If new gases are being released, SVI will identify them. And because USER is not observing from Earth, because it has a different vantage point in space, it can see details that Earth-based telescopes might miss. The timing is critical. USER is observing less than a week after perihelion. Whatever happened in that hidden window, the thermal effects will still be apparent. If 3IAtlas experienced a major outgassing, the comet's coma will be expanded and bright. If structures were released, they won't have had time to separate significantly. If the orbit changed, the deviation will be measurable. USER is positioned to catch 3IAtlas right in the immediate aftermath, before the evidence fades or dissipates. But there's a catch. The USER data won't be available immediately. The spacecraft is currently far from Earth, on the opposite side of the Sun. It's using its medium-gain antenna to communicate, because the main high-gain antenna is being used as a heat shield against solar radiation. The data rate is slow, very slow, and the distance means the signal travel time is significant. The European Space Agency has stated that they don't expect to receive users' observations of 3IAtlas until February 2026. A 4-month wait to see what users saw. That delay is both frustrating and suspicious. If user captured something extraordinary, something that changes our understanding of 3IAtlas, we won't know about it for months, and by the time that data is released, the object will have made its closest approach to Earth, past Jupiter, and moved beyond the point. Where interception or further study is feasible, the information will be history, interesting, but no longer actionable, unless, of course, the data is analyzed in real time by mission controllers, and appropriate decisions are made behind closed doors, without public disclosure. While we wait for the user data, 3IAtlas continues its journey. In late November, it emerges from the sun's glare and becomes visible to Earth-based telescopes again. This is when the International Asteroid Warning Network's observation campaign officially begins on November 27th. Workshops have been held. Participants have been vetted. Protocols have been established. And now, every night for the next 2 months, coordinated observations will track the object as it moves through the constellation Virgo, low in the pre-dawn sky. This is when amateur astronomers get their chance. 3IAtlas will reach an estimated magnitude of 12 to 13, too dim for the naked eye, too dim for binoculars, dim but within reach of an 8-inch or larger telescope under dark skies. And there are thousands of amateur astronomers around the world with equipment capable of imaging it, who are not bound by institutional protocols or data embargoes, who will post their observations online within hours after taking them, who will compare notes, analyze orbits, and detect anomalies that official channels might prefer to keep quiet. This is the democratization of discovery, the moment when the truth, whatever it may be, becomes impossible to suppress because you can't control data that belongs to everyone. You can't embargo observations made by independent researchers who owe nothing to the National Aeronautics and Space Administration, or the European Space Agency, or any government agency. The whistleblowers predicted this, they said. December would reveal everything to home observers. And they were right, not because the object would necessarily do something dramatic, but because the sheer number of eyes on it guaranteed that any deviation from expected behavior would be recorded, shared, and debated before official statements could shape the narrative. October 19th is the key date, closest approach. 1.88 astronomical units from Earth, 269 million kilometers, still more than 700 times the distance to the Moon, still too far for any immediate threat, but close enough for high-resolution spectroscopy, close enough to resolve the nucleus from the coma. If the object is large, close enough to detect any unusual emissions or secondary objects that might be trailing it. And this is what we should be looking for. First, the orbit. Has it deviated from the purely gravitational path, predicted by the orbital elements calculated back in July? Even a tiny shift, a fraction of a degree, would indicate non-gravitational forces at play. That could be cometary outgassing, or it could be something else. Second, the spectral signature. Does the object still show nickel emissions, without the iron? Which is strange as the carbon dioxide to water ratio still unusually high. Have any new chemical species appeared that weren't detected before? Third, the morphology. What does the coma look like? Is it symmetric or skewed? Are there jets pointing in specific directions? Is the nucleus still obscured by dust, or has it become visible? And fourth, any companion objects. Has the object fragmented? Are there smaller pieces following the same orbit? Or, in a more speculative scenario, Are there secondary objects moving independently? If BAI-Atlas behaves like a natural comet, we should see fragmentation. Comets often break apart as they approach the sun. Thermal stress, outgassing, tidal forces, all work together to fracture the nucleus, especially for an object that has been wandering interstellar space for potentially billions of years. Its ice and rock would be pristine, never before heated, never before stressed. A first pass near a star can wreak havoc. We should see fragments. We should see a trail of debris. We should see the object slowly disintegrating as it moves away from the sun. If that happens, the comet hypothesis is confirmed. BAI-Atlas is natural. All anomalies have mundane explanations. The composition is just unusual chemistry. The orbit is just statistically improbable, but not impossible. The activation of the International Asteroid Warning Network is precautionary. It's a way to test coordination protocols on a real target, and for all of us to relax and appreciate this rare opportunity to study an interstellar visitor up close. But if it doesn't fragment, if the object maintains structural integrity, if it passes perihelion without breaking up, that would be anomalous. Most comets don't survive close passes intact, especially not comets that are interstellar and have never been heated before. And if BAI-Atlas not only survives, but also shows no signs of significant outgassing, no debris trail, no pieces breaking off, that raises serious questions about what it's made of, about whether it's held together by something other than gravity and ice, about whether its structure might be artificial. Then there's the Jupiter flyby on March 16th, 2026. BAI-Atlas will pass within 54 million kilometers of the gas giant. NASA's Juno spacecraft will be in position to observe. Juno has an ultraviolet spectrograph, an infrared mapper, a microwave radiometer, and a suite of instruments designed to study Jupiter's atmosphere and magnetosphere, but they can be pointed at a comet, and at a distance of 54 million kilometers. Juno will have one of the closest views of BAI-Atlas we'll ever get from a spacecraft. This is the final data point, the last chance for high-quality observations before the object leaves the inner solar system. If BAI-Atlas is going to do something unexpected, if it's going to perform a maneuver, or deploy secondary payloads, or reveal its true nature, the Jupiter flyby is the logical moment. It's far enough from the sun that solar interference is minimal, and close enough to a large planet that a gravitational assist is possible. And it's positioned where NASA has an asset that can record everything in detail. But again, there will be a data lag. It takes time for Juno to transmit, time to process, and time to analyze. By the time we see what Juno observed, BAI-Atlas will already be on its way out of the solar system. It will be moving toward the outer planets and eventually back into interstellar space. The window for interaction will have closed. If there was something we should have done, a mission we should have launched, a response we should have coordinated, it will be too late. That's the frustrating reality of astronomy. We are always looking into the past. Light takes time to travel. Data takes time to transfer. Analysis takes time to complete. By the time we understand what we're seeing, the moment has passed. BAI-Atlas is here now, moving through our solar system, and we are scrambling to gather data before it leaves. In a few years, it will be gone, a receding point of light, growing fainter and fainter, until even our most powerful telescopes can no longer track it, and we will be left with whatever information we managed to gather in this brief window, unless it doesn't leave, unless the offset maneuver happens, unless the object decelerates during perihelion and enters a bound orbit. Then BAI-Atlas would remain in the solar system. It will orbit the sun on a long, elliptical path, returning in a few years or several decades depending on its new trajectory. and we will have ongoing opportunities to study it, to send missions to intercept it, to find out what it truly is. That scenario has not been ruled out. We will not know until November, when the object becomes visible again, and we can recalculate its trajectory based on post-perihelion observations. If its velocity is lower than expected, if the orbit has changed in ways that trap it near the Sun, we will have confirmation that something happened during those hidden weeks. Behind the Sun, something changed the object's fate, and we will have to face the implications of that. There is another possibility we should discuss: the consciousness shift theory, with videos and posts spreading proclamations, stating that on October 30th at 11:44 Coordinated Universal Time, it will coincide with a global electromagnetic event affecting human consciousness, a calculation of Schumann resonance amplification, with predictions of technological failure and the mass synchronization of billions of minds. This theory has captured the imagination, but it lacks a scientific foundation. The mechanisms described do not align with how electromagnetic fields interact with biological systems, and claims of observing a shift in December are vague and unverifiable, but it speaks to something deeper, a longing for meaning, a desire for this object to be more than just a comet, a hope that something extraordinary is happening, something that will change us, elevate us, connect us to the cosmos in ways we have never experienced. That longing is human. It is understandable, but it should not blind us to the actual data, to the real science being conducted, by real telescopes gathering real information that will either support or refute these extraordinary claims. If Bialas affects the Earth in some way, it will be measurable. It will appear in our instruments. It will be recorded by magnetometers and radio telescopes, particle detectors, and all the other sensors we use to monitor our space environment. We will not need to rely on subjective experience or anecdotal reports. The data will tell us what happened, and if the data shows nothing unusual, then the consciousness shift theory will join the long list of apocalyptic predictions that did not come to pass. So where does that leave us? We have an object with multiple confirmed anomalies. We have space agencies that have activated planetary defense protocols while maintaining public silence about crucial data. We have a whistleblower claiming evidence of artificial signals. We have scientific papers exploring the possibility of extraterrestrial technology. And we have a countdown to a series of observations that will either confirm this is all a natural phenomenon or force us to reconsider everything. We think we know about our place in the universe. 60 days. That is the window until mid-December. We will have enough data to draw informed conclusions. The International Asteroid Warning Network campaign will be underway. Thousands of observations will be recorded. The trajectory will be recalculated with high precision. Spectral signatures will be analyzed. The morphology will be documented. And we will see if this object follows the script for a comet, a natural comet. Or if it is writing its own story. I want to be clear about what I think is most likely. The simplest explanation is often the correct one. 3IAtlas is probably a comet, a large comet, an unusually, scientifically fascinating one from another star system. The anomalies probably have natural explanations that will become clear as we gather more data. The activation of the International Asteroid Warning Network was likely precautionary, a way to test coordination protocols on a real target. The whistleblower is probably someone with partial information, or someone who fabricated the claim for attention, and December will likely be an anticlimax, with the object behaving exactly as a comet should. But maybe it's not a certainty, and the data we have now leaves room for doubt. It leaves room for other possibilities. And that is why we watch, why we wait, why we keep our telescopes aimed at this visitor and record everything it does. Because if the unlikely turns out to be true, if 3IAtlas is something other than natural, we want to know. We need to know, and we will know soon. October 19th. Mark it on your calendar. Look for 3IAtlas in the morning sky if you have the equipment. Follow the discussions online. As observations come in from around the world, watch to see if NASA or the European Space Agency finally break their silence and release the data they have been withholding. And consider what it means if this object, this interstellar visitor appearing in our skies, with its perfect timing and impossible alignment, turns out to be our first confirmed encounter with technology from beyond Earth. The truth is out there, literally moving through space at 210,000 kilometers per hour, and in 60 days, we will have our answers. Not the final answers, perhaps not absolute proof, but enough information to know whether we are alone, or whether something from the dark forest has come to see what all our noise is about, whether we have passed the test, or whether we are about to find out why the universe is so quiet, whether 3IAtlas is a comet or a message, and what that message means for the future of humanity. The countdown has begun. The telescopes are ready. The observers are prepared. And somewhere behind the sun, hidden from view, 3IAtlas continues its journey toward the moment when all eyes will be watching, and all secrets will be revealed.